We're Mr. Bubbler Incorporated, and this is the Bubble Maker 2014. I'm Cody Sams.
My name is Mark Morales.
My name is Abdul Zabar.
Christopher Miller.
Okay, we're going to jump into a brief overview of how our presentation is going to go here. We're going to talk to you about our design process quite a lot because we had a lot of initial ideas of where this wanted to go, a lot of kind of Debbie Downers where it did go, and a lot of modifications up till about 10 minutes ago. In our initial kind of first day sitting around brainstorming where we wanted it to go, we considered two possibilities. One, a design that utilized a series of gears, and a design that utilized a simple pulley. We started drawing up gear ideas and found out pretty quickly that it was going to require a lot of time and a lot of complicated mathematics to really make those gears precise, so we decided to jump into a pulley design.
No, that's good.
Our first initial pulley design was actually a huge success, and we just kind of ran away with it and printed off our container here from the EMPACTS Lab 3D printer. Only designed to really utilize one pulley. Our final design, we were hoping would utilize 3 pulleys to slow down our bubble wheel because our initial motor was far too powerful, and when we ran it, it actually shot solution all over the walls and made a huge mess.
We had another design actually for the 3D machine, but 3D machine broke down, and that was the one that was going to have 3 pulleys because we were going to run both the wheel and the fan out of one motor, but we couldn't get it.
Right. The file was so large it actually crashed the computer for the 3D printer. That was fun.
Yeah, part of this design, I mean, when we started, we tried and error. First we started with the simple pulley. We have a big design with a big container, but that wasn't meeting one of our criteria, which was to be portable. So we come up with the container. Like he said, I mean, we had 2 designs. We had one that we were supposed to use gears, and the other one was use pulleys. There, at this point, at the beginning of the process, both options were very possible, and they were considering them. But we got into the problems with the 2D printer and designing all of the gears and stuff that was going to take longer, and it's going to be harder to keep them all in one place to work all together. So we come up with a container. Part of the design of our bubble machine was mainly try to make it portable and easy to use. So the best way to work that was to just use the pulleys and try to make, basically the container is the main machine, is the main thing. So we're basing all our parts in the container.
Yeah, at the very beginning, the first design was the pulley was running on one side and the container was another one. So we thought that to put them together would be a better idea. So we came up with this, and we're actually gonna have a new wheel, but as he said, the 3D machine went down, so we wouldn't be able to print it. And I think we should try it out.
Like we said, we had to do little modifications to it.
Actually, the holes for the wheel are kind of big. That's why the bubbles are going to be so big. We have another design for the wheel, which is going to have really small holes, and hopefully it's going to have the bubbles come out.
Yes. Our bubble solution, which you just saw in action there, it's pretty nice. It's made up of a simple water, Dawn dish soap, and a glycerin mixture. Nothing real complicated about it. get those out of any website, anywhere out there. Homemade bubble solution.
Let's talk about the cost. It actually didn't cost us that much since we used the 3D machine. It didn't cost us at all. I think all in all, $45. I think we'll be able to pump that number down by
With all the modifications and everything all together, you probably maybe wanted like 35% profit.
yeah.
So altogether, its price would be about $10.50 with 35% profit. Altogether, in the design process, with all of our test trials and failed designs, everything came together to be about $45–50, and again, a 35% profit. It's shelf price excluding shipping costs and all kinds of other weird costs that I found on the internet. It's gonna be a shelf price of about $10.50. And that's really all. It's about as complicated as it got for us. Do we have any questions?
Is that the only wheel that you utilize?
Yes, thus far this is the only wheel that we've utilized. We are hoping to have a better wheel by tomorrow. But again, we crashed the 3D printer.
So how many print attempts did you have? Were there any other major issues with 3D printing?
Well, technically, that's as far as the container, it's the only one that we got from the 3D machine. We printed a lot of stuff using the 3D machine. Like first, we started with the gears, but they didn't mesh, so we ended up using the pulleys. But the only thing the two things that we use the 3D machine to print out is the wheel and the container.
We didn't really have any big problems with the 3D printer. It did its job, it did it well. We just tried to feed it too large a file and it couldn't process it in time. It calculated our last container that we were going to use to be about a 14-hour print. So it's kind of it's a rather large file. Anything else?
What are the advantages as far as pricing and design to other like replacement products in your market?
The advantages, placement designs.
Like pricing compared to other products that are comparable in your market, and your design versus their design. Like
Their designs are utilizing large motors that cost a lot of money. Like even just a remote control car is going to be about $25 on the shelf because of its little motor inside of it. That's the bulk of its cost. Ours, its first motor, it was about a $60 motor, and our shelf price, our first shelf price for the original product, what was it? It's like $40 somewhere in there. It was expensive. These two little motors,
It's like $3 each.
$3 each.
Yeah.
So $6 total price for these motors. Not a lot. A big difference in shelf price from $40 down to $10.50. The motor difference there was a big factor.
So what kind of design issues did you have with the big motor, with just the price factor that you ended up?
We mounted the big motor on there the first time. It actually broke off our support right here.
Yeah, it was making the wheel go too fast.
Shooting
We
solution
needed a
all
fan to
over.
go fast, but the wheel was going too fast, and it was just throwing the solution out of the container.
Yeah, one of the main things was in the first design that we had was to just work it with one motor, which was trying to make the fan and the bubble wheel spin different, because the bubble wheel has to go slower than the fan. So we were trying to figure out the way to keep the motor from making everything go so fast. So we come up with the pulleys, which one of the problems that we had too, that our motor, or originally one that we had, was a little bit too strong and was making the whole thing like split, was splitting everything out of the container. So, and yeah,
Tried to dampen it down with a series of pulleys, but we really couldn't fit too many pulleys on this container. So we really had to kind of sit down and brainstorm, go back to the drawing board. This morning, actually, we decided the large motor's not gonna work. We really can't come up with a way to dampen it down and kind of stick to our portable design idea. So just kind of sat back and said, what if we did 2 motors off 1 switch? 2 really small, cheap motors off 1 switch. It's worked out so far.
What is the ideal RPM that you found for each,
Bubble wheel?
the bubble wheel and the fan?
Jeez.
Like, what would you estimate
Sure,
your
right,
wheel,
yeah.
what your rotations per minute would be on the wheel?
It'll be probably, the motor goes 45 round a minute, and
Rotation.
with the gears, rotation, with the gear, or with the pulley, I'm sorry, I think it goes down up to 10 round per half a minute,
Yeah.
so.
It pulled out like half the time. The relation.
Yeah, that one was crazy.
2-to-1. So you have a 2-to-1 gear.
Yeah, 2.
Yeah.
And if we put the point of comparing our product to the products from the market, from the Spotlight, I think this product has got an advantage according to its weight. So I think the products of the market got a little bit weight because they use a blower and all that. And we were thinking to make the wheel and the container run by 1 motor,